Hello and welcome. My name is Eitan Suez, Technical Marketing Manager at Solo.io, and in this lesson I will cover AI consumption reporting with kgateway. So just to set some context, kgateway is a control plane for Envoy. It allows the creation of gateways, of course, for routing and managing traffic. And it also has AI capabilities. It supports proxying calls to LLMs. And that means that we can provision an AI gateway that will proxy calls to LLMs, and it has specific capabilities. It helps manage credentials, for example. So in lieu of client applications managing their own API keys, those can be sort of associated with requests by the gateway. We have features such as prompt guards and prompt enrichment, which also facilitate and secure calls to LLMs and perhaps mask sensitive information. Or constrain the scope of prompts, which is important from a security standpoint, and features such as model failover, which allow calling to secondary or tertiary models when the primary one's unavailable. So if we were to illustrate what this looks like, right, in an environment, this could be a Kubernetes cluster. We have an ingress gateway that routes incoming traffic to backend applications, and some of these applications today are LLM applications, they LLM clients anyway. They make calls to perhaps external LLMs. Those could be hosted LLMs as well. And the idea is to make those calls through an AI gateway, a form of egress gateway that's bespoke for AI workloads. And one of the capabilities of this AI gateway has to do with observability. So in addition to all of the other features that I mentioned, observability and telemetry are another important and complementary function of an AI gateway that helps us monitor AI traffic and also be aware and report on AI consumption. So this is important for security reasons and as well as cost control. And so let's delve into how this exactly works and how we can configure kgateway with an AI gateway for the purpose of monitoring AI traffic. And the story sort of begins with a feature in Envoy known as dynamic metadata, which allows this AI gateway to capture AI-specific metadata with requests. And we can expose those in access logs, as you see in this screenshot here. This is just a line from the access logs that shows, in addition to maybe the typical fields like protocol and method and authority and path. Here we make a call to the Mistral AI, to the V1 chat completions endpoint. But besides bytes sent and bytes received, we also see which model we actually called to, how many prompt tokens we utilized, how many completion tokens we got back, and AI-specific information. Now this information is actually used as a building block to constructing metrics. And so kgateway has on its AI gateway a metrics endpoint that we can use for monitoring tools to scrape. And so here you see a list of the usual, the typical metrics you will see is things like AI prompt token total. These are counters, and notice this is broken down by model as well, so you can see exactly how many tokens you used when calling out to, for example, the GPT-4o mini model. This can be further customized if necessary to also include additional dimensions such as the team that actually made the call, and so you can then have more fine-grained information about utilization by team, for example. And so these metrics can then be ingested by Prometheus and reported on by Grafana or whatever observability stack that you utilize to monitor prompt and completion token usage, to monitor the rate of token consumption, which is also very important, and to establish baselines and thresholds for utilization. We can configure alerts if we want to, and also configure rate limits to prevent overutilization, for example. And so let's demonstrate how this works by going through an activity in a hands-on lab where we'll make some calls to some distinct LLMs and inspect this AI metadata in the access logs, and then we'll proceed to look at the metrics endpoint, and then maybe take a look at the Grafana dashboard that I put together, and finally configure rate limiting to calls to a specific LLM. Okay, so here we are in a lab environment. This is an instruct lab environment. We'll go ahead and click start, which will put us in an environment where we have a running Kubernetes cluster. Maybe we first should establish what we have going on here. I can look at the fact that I have an AI gateway already provisioned in my cluster, and I have a couple of HTTP routes as well. Let's take a look at those. So one is called Mistral, one is called OpenAI, and they map to the /Mistral/OpenAI endpoints. And so we can call out to either of these by making a call through the AI gateway. And so let's begin by looking at a configuration. This is an HTTP listener policy. It's a custom resource definition in kgateway that allows us to customize access logging. And here what you see that I configure access logging to use JSON format. And some of the latter fields that I specify there at the bottom are LLM specific or AI specific pieces of metadata, things like prompt tokens and completion tokens and so on. And so we can apply this HTTP listener policy. And then we can proceed to make a call, and this may be worth dissecting real quick to see exactly how I make this call. This is a call from a supposed workload running in my cluster, the curl image, and from there we're going to make an HTTP request, a JSON request to the Mistral endpoint with a payload that with a particular prompt there, a user prompt. What is the best French cheese? And so we make the call, and that goes through the gateway, and we get a response. Okay, so what we can do is tail the logs and maybe format it through JQ to actually see the access logs containing this metadata, things like prompt tokens, completion tokens, total tokens, the provider, the model, and so on. So all of this is captured. And this is sort of the building blocks for the metrics that are also exposed by the gateway. And so the next thing we'll do is we'll look at some of those metrics. We have a gateway parameters resource. Let's take a look at that. Gateway parameters resource, which is configures the AI extension. And when we look at it, we'll notice that we configure a particular port, the AI monitoring port, to use the port number 1992, so 9092. And it's through that port, there's an endpoint called /metrics that we can use to actually look at some of the AI-specific metrics that are exposed. And so if I were to call, for example, a second LLM, notice that in this case, I'm going to call the OpenAI endpoint through the gateway, specifically so that when I look at the metrics endpoint, maybe one simple way to do that is to port forward the port 9092 and then to make a call to this metrics endpoint. And here you see a variety of metrics, the prompt tokens and completion tokens per model and per provider that have been captured so far, because I've made two requests, one to each of two distinct models. And so these metrics are captured. Now I have in this environment a sort of Prometheus observability stack already deployed. We can actually inspect some of it. It's not perhaps too interesting. In the hotel namespace, I have an OpenTelemetry collector, and in the monitoring namespace, I also have Prometheus and Grafana, and Prometheus is configured to sort of obtain the metrics through the OpenTelemetry collector, which is in turn configured to grab both the Envoy metrics and the AI extension metrics. And then we can use Grafana dashboards, for example, to essentially view those metrics or display those metrics in any way we want. So let me make a couple of additional calls. This is not going to exercise the system very much, but we have here a Grafana tab, and in that tab we can log into Grafana, which is running in my cluster. We'll log in with the default credentials, and you will see that there's a sort of a custom dashboard that I built real quick that sort of exposes those metrics. So here you can see the Mistral prompt and completion tokens and the OpenAI prompt and completion tokens. These are counters, of course, and we can, of course, enhance a dashboard to include things like the rate Prometheus expressions that allow us to capture or to get a sense for the baseline for the rate of token utilization, both in either direction to each LLM. The last piece of exercise that we do here at the end of this lab is to look at just a simple configuration of rate limiting that allows us to perhaps target a very specific route. So here we want to rate limit calls to OpenAI. In a more realistic scenario, we'd probably do that by team or by user. But in this case, just for illustration, I'm showing essentially a rate limit of one request in a 30-second window, just for the sake of being able to trigger it. And we can apply this rate limit. And once we do, we can simply send a couple of calls to the OpenAI endpoint. And we should see that the first one succeeds, but the second one will actually return a 429 too many requests. So the rate limiting capability of kgateway can be brought to bear to control consumption to LLMs and AI workloads. So let's go ahead and wrap up. In summary, observability and consumption reporting are an important capability enabled by gateways, and it's equally applicable to traditional gateways and AI gateways. Kgateway, as we saw in this lesson, has support for AI-specific metrics for monitoring AI traffic and prompt and completion token usage. And so we can make use of it to essentially control spend and otherwise monitor our AI traffic. All right, thank you very much for your time, and we'll see you in another lesson. Bye.